Hi everyone, welcome to Nithin Academy and I'm Nithin. I hope you have watched my previous video on chemical composition. If you have not, please do, because it will help you out in understanding this chapter more easily. And today in Secondary 1 Science, I'll be moving on to the next chapter, separation techniques. Okay, so let's dive straight into it. Okay, so for the first segment of this video, I'll be going through magnetic attraction. Okay, so magnetic attraction is basically one of the 5 separation techniques that you're going to learn today. Okay, so let's get started. Okay, magnetic attraction. So this is technique number 1. So let's get started. So magnetic attraction is basically magnetic substances such as ions, steels are attracted to a magnet, and glass, rubber, plastic, and paper are non-magnetic. Okay, so this is something that you know, right? So magnetic substances are like iron and steels that are attracted to a magnet. Okay, so they are attracted to a magnet, while non-magnetic materials are not attracted to a magnet, such as glass, rubber, and plastic, and paper. Okay, so next, magnetic attraction can be used to separate magnetic substances from non-magnetic substances. Okay, so this saves time and effort instead of like taking pieces one by one. Okay, so let's take a look at an example over here. Okay, so this example is basically sulfur. Okay, sulfur is a chemical, and iron filings. So we are going to actually add these two into the same mixture. So we have a mixture of iron plus sulfur. Okay, and if we put a magnet over here into the mixture, basically the iron filings will actually attract to the magnet while the sulfur remains behind. Okay, so I hope you understood that. So why does it save time and effort? Because instead of taking the iron filings one by one, we could do this, right? Okay, next. Okay, so this is what I've just said. For example, when a magnet is placed near a mixture of iron filings and sulfur, only iron filings are attracted to the magnet. Sulfur, which is a non-magnetic material, is left behind. Okay, so this is basically the example that I've shown you for magnetic attraction, and this experiment is most probably done during science lessons. Okay, so when you're learning the separation techniques, you might go to the lab and do this experiment, right? Okay, so something important that you need to take note, right, is over here, this yellow box. Okay, so the target substance must be magnetic and the rest must be non-magnetic. So over here the target substance is actually iron filings, right? So it is magnetic. Okay, so this is the number 1 rule that you need to take note of. So let's move on. Okay, so again, in magnetic attraction, we are going to take a look at the application of magnetic attraction. Okay, so the application is that in a scrapyard, magnetic attraction is used to separate magnetic substances from the non-magnetic substances. Okay, so this is what it looks like. So this is basically a huge electromagnet which actually attracts all the metals away from the non-magnetic substances. Okay, so it attracts all the magnetic substances while the non-magnetic substances are left behind. Okay, so this is the application. Now let's move on. Okay, so for the second segment of this video and the second separation technique, I'll be going through evaporation. Okay, evaporation. Okay, the technique number 2, evaporation. So this is what an evaporation setup looks like. Okay, so it's basically a solute. Okay, do you remember what solutes and solvents mean? Solute is basically the thing that you're gonna dissolve in the solvent. Okay, the thing that dissolves in the solvent. Okay, while the solvent is basically the thing that okay, the thing that solutes dissolve in. Okay, so it's basically so this is from the previous video, chemical composition. So I've actually explained to you about solutes, solvents, and yeah, so I hope you understood that easily. Okay, so now let's take a look at the actual evaporation setup. Okay, so a solute, which is basically the solid, and a solvent, which is the liquid, can be separated using evaporation. So this over here is salt solution. Okay, salt solution. So this basically the evaporation setup. So here we have a evaporating dish, this is a wire gauze, and this is the tripod stand. Okay, tripod stand, you could also tell it as a tripod. Okay, and this over here is the Bunsen burner. Okay, okay, next, the solvent, okay, which is basically the liquid that the solute dissolves in, changes state from a liquid to a gas at a much lower temperature than the solute. Okay, because the solute actually has a higher boiling point, so it changes from a liquid to a gas at a much lower temperature than the solute, and the solute is actually in the form of a solid when we were like doing the salt solution. Okay, so when you're adding salt, right, it's actually in the form of a solid. Okay, okay, next, so basically what happens is that the solute is left behind, is known as residue. Okay, so basically the salt will be left behind over here in the side. So while the water evaporates slowly, the water level decreases, right, and then it just forms on the sides. Okay, the salt, and then again it like decreases, then it just forms, and then until all the water has evaporated. Okay, then we will get the salt which is left behind. Okay, so the salt will be left behind, and then so something important that you note, right, is that the solute must not decompose under heat. So the salt must not decompose under the heat of the Bunsen burner. Okay, so actually it will be really hot when you take it out, so you have to off the Bunsen burner, and you have to let it cool down for a while, because if you immediately go touch the evaporating dish, you might burn your hand. Okay, so please do take note of that. So this is basically the evaporation setup. Okay, so I hope you understood that. Now let's move on. Okay, next, application of evaporation. Okay, this is something that I hope you know. Okay, in a salt pond, okay, do you know what's a salt pond? So it's basically this pond where water evaporates due to the heat of the sun leaving salt behind. Okay, so people actually gather like that, they gather like water. Okay, over here, see this salt water, so they like block it using this dirt over here, and then all the water actually evaporates and leaving salt behind in the form of hills. Okay, so I hope you understood that, and this is the application of evaporation. So separating salt water from separating salt from seawater. Okay, so I hope you understood that. Now let's move on. Okay, next, still in evaporation, another application is something like this. Okay, so you see all these dried foods, right? So bacteria actually grows well in moisture. So in order to actually preserve these foods for a longer period of time, right, we actually the food with higher water content will spoil much easily. So basically it means that it has a short shelf life. So this means that you can't eat it, if it's like too long. Okay, because it will actually spoil. Okay, next, to increase the shelf life, right, some food are put through evaporation, so basically leaving the food in the sun. Okay, so leave in sun, right, leaving it in the sun, so it actually evaporates and it dries up. So these are the dried fruit products you get. Okay, so dried fruit, and this is actually really sustainable. It won't spoil for a very long period of time. Okay, so I hope you understood that. Now let's move on. Okay, so for the third segment of this video, I'll be going through filtration. Okay, so filtration is the third separation technique. Okay, filtration. Okay, so something that you need to know. So this is an example. Okay, so in Vietnamese coffee. Okay, so in Vietnamese coffee, so this is how they make the Vietnamese coffee. The fin actually acts as a filter paper. Okay, it acts as a filter paper to only allow small particles to go through. So these small particles are actually water and extracted liquid coffee. Okay, so here, this part over here, you see this circular part over here, that's the fin. Okay, and bigger substances such as the coffee beans actually will be left behind over here. So the coffee beans will be left behind and cannot go through the filter and is retained in the fin. Okay, so basically what you need to take note of, right, something really important, is that the residue must be insoluble. Okay, the residue must be insoluble, cannot dissolve in water. Okay, so basically the coffee beans cannot dissolve in water. Okay, if it is soluble, right, basically if these coffee beans were soluble, right, they will actually dissolve in the water and it will actually come out in the coffee itself. So there will be nothing retained. Okay, so I hope you understood that. Now let's take a look at the actual filtration setup. Okay, so this is the actual filtration setup, and an experiment that you might do in secondary school. Okay, so basically there's a mixture of water and sand. Okay, so the filter paper over here and the filter funnel. So basically you're gonna pour this mixture into here, and then you'll get water over here, basically being the filtrate. So this will be water, and left the residue will be sand. Okay, and sometimes, right, you know the evaporation setup. So basically sometimes the teacher might ask you to add salt inside here as well. Okay, so when you add salt, right, this will actually be salt solution with sand in it. So when you get over here, right, it won't actually be water. The filtrate won't actually be water, it will be salt water. Then the teacher will ask you to do the evaporation setup, you know. Then we got the wire gauze here, and then we have to do the evaporation setup. Heat. Okay, so this is what the teacher will ask you to do, most probably, because the teacher is not gonna do this experiment in 2 times. Okay, so the teacher won't actually do this experiment, one for evaporation and one for filtration. They will actually combine these two and do it together. Okay, even for your practical exams, this type of experiment might come out. Okay, so you have to take note of all the experiments that I'm going through in this video. Okay, so let's move on. Okay, so next, simple distillation. So this is the fourth separation technique. So this is simple distillation. Okay, so this is what a simple distillation setup looks like. Okay, so this is how a simple distillation setup looks like. So firstly, substances that boil at different temperatures can be separated using distillation. Okay, so that boil at different temperatures. Okay, boil at different temperatures. So this is something important that you need to take note of. Okay, next. So first, what happens, right? So the lowest boiling point will change into vapor first. Okay, so if we have water, okay, over here is salty water, right? Salt water basically. So water has a lower boiling point than salt. So basically the lowest boiling point will change into vapor first. So water will change into vapor first. It condenses when it touches the cool surface of the condenser. So this is basically the condenser, and cool water will be going around over here. Okay, cool water over here will be actually moving around that condenser in order for it to stay cool. And when the warmer water vapor comes into contact with the cooler surface of the condenser, it will actually condense and form water droplets, and it will come out of this tube and land into this beaker, and it will give us pure water. Okay, so it will actually be distilled and it will be collected into the flask and beaker. Okay, next, so distillation is basically a process that separates substances with different boiling points through evaporation and condensation. Okay, something important that you need to take note of is that simple distillation will not work properly when the difference between the two boiling points is 25 degrees Celsius. Okay, so it needs to be more than 25 degrees Celsius, or okay, so please do take note. It would not work if the difference between the two boiling points is 25 degrees Celsius. So it needs to be more than 25 degrees Celsius. Okay, so next, so something one more thing that is very important over here is that the substances must have different boiling points. Okay, so this is the most important thing that you need to take note of. I've already highlighted it over here as well. Okay, so I'm just showing this to you guys so that you understand truly. Okay, so let's take a look at how the distillation setup is set up. Okay, so here we actually have the Bunsen burner. Okay, Bunsen burner. So actually there will be a retort stand over here. Okay, so there will be a retort stand holding on to the thermometer and holding on to the conical flask, and if there's not a retort stand, right, actually there will be a tripod stand over here. Okay, with the wire gauze holding this conical flask in place, and this condenser is actually attached to this part over here, and okay, and the vapor that rises will actually go through the condenser, and pure water will be collected in the beaker below. Okay, so this is basically the distillation setup. Okay, so I hope you understood that. Now let's move on. Okay, next, so this is the last separation technique. Okay, so the last separation technique, paper chromatography. Okay, so paper chromatography. So paper chromatography is basically a separation technique that separate different substances in a mixture accordingly to their solubility, ability to dissolve in solvent. Okay, according to their solubility. Okay, so take a look at this. This is basically a paper chromatography setup. Okay, so different substances have different solubility in a solvent. Okay, the more soluble the substance is, the farther the distance it will travel from the starting point. Okay, so basically what we need to do, right, so we need to take a pencil. So at the start of every paper chromatography experiment, right, so we have a piece of paper hanging down here. Okay, and then we have to take a pencil and a ruler and draw a straight line. Okay, so this is the pencil line we need to draw. Okay, so this is where we will put the ink drop. Okay, and it must be above water level. So if this is water level, right, it's actually above water level. Okay, so it needs to be above water level. If not, right, it will start to, if not, the water will actually start to rise up the paper even before you put the ink spot. Okay, so when you put the ink spot, the water level will slowly rise and the ink will also rise, okay, together with the water. Okay, so So different substances have different solubility, right? So the more soluble the substance is, the farther the distance it will travel from the starting point. So if we put a different substance here, right, the ink spot, it will actually travel a further distance if it has if it's more soluble. Okay, and some things you need to take note, right? Okay, so this ink spot, right, actually created a lot of colors such as yellow, pink, orange, blue, purple. Okay, so all of this color lies into this ink spot. But pure substances, right? So pure substances actually only create one dot. So basically, right, what I'm trying to say, right? So this dot over here, right? When the water rises, only another dot. It can form anywhere on the paper. So it can form here, it could form here, it could form here, anywhere. But it should be only one dot. Okay? And if one dot forms, right, it means that the substance that you have put on the piece of paper, right, is actually a pure substance. Okay? Okay, so next. Okay, something that you need to take note of. The substances must have different solubility. So this substance and the water must have different solubility. Okay, you can't put this ink spot and the same ink as the solvent, right? So basically, if it's the same, right, it won't work. The paper chromatography won't work. Okay, so I hope you understood that. Now let's move on. Okay, so for the last segment of this video, I'll be going through water in Singapore, and I hope you have understood paper chromatography. So now let's take a look at water in Singapore. Okay, so let's take a look at water in Singapore. So this is basically like one of the sources of water from Singapore. Okay, so this over here is basically the 4 uses of water. So let me just write that down. 4 uses of water. Okay, so this is the 4 uses of water. Okay, first use is essential for all living things to maintain our body function. Okay, so this is the first use. Next, it is used in industries to fabricate, process, wash, dilute, cool, and transport products. Okay, so these are the uses of water. So these are the uses of water which is used in industries. Okay, so water is also used required in homes for cooking, washing, and cleaning. So basically for household use. Okay, so water is also used for water activities, so basically for recreational purposes such as swimming and canoeing. Okay, so these are the 4 uses of water. Now that we have taken a look at these 4 uses, now let's take a look at the 4 national taps. So let me just write that down. 4 national taps of Singapore. Okay, the 4 national taps. So the first national tap is water from local catchment. So rainwater is collected through a network of drains, canals, and river. The water collected is then channeled to 17 reservoirs for storage. Okay, so I hope you understood that. Now let's take a look at the second tap. So it's basically imported water. So Singapore continues to import water from Johor under the 1962 Water Agreement. Okay, so this is the 1962 Water Agreement, which allows us to draw up to 200 million gallons per day from the Johor River until 2061. So we still have about 40 years, plus minus, okay, 40 years before we are totally before this agreement runs out. Okay, next. So Singapore also has this thing, new water. Okay, so I hope you know that new water. So it's basically an ultra clean, high grade recycled water, which is basically obtained from treated used water through microfiltration, reverse osmosis, and ultraviolet disinfection. So there's a lot of processes in order to make new water. Okay, and the last national tap of Singapore is desalinated water. So it's basically by obtaining pure drinking water from seawater through a process called desalination using distillation or reverse osmosis. So distillation is one of the separation techniques that you have learned, right? So it's basically by using distillation or reverse osmosis. Okay, why I'm telling this to you, right, is basically because you see these two over here, new water and desalinated water, actually applies the separation techniques, okay? Separation techniques. Okay, so it actually applies separation techniques. So basically to separate seawater, so basically to separate water from seawater. Okay, so I hope you understood this, and with that I've come to the end of this video. Okay, and thanks for watching, everyone. I hope you have enjoyed this video and understood more about secondary 1 science, the fourth topic of separation techniques. And I hope this video really helps you, and if you're not subscribed to Nithin Academy, please do subscribe and be a part of our family. Thank you and bye bye. I'll see you again in my next video. Bye.